In today's lesson, we're going to review scientific notation, and we're going to use the laws of exponents to help us do that. We'll start with a quick recap of what scientific notation is, and then we'll go over how to multiply and divide expressions with scientific notation. So in the recap here, I've written down a times 10 to the b. So a represents our coefficient, and an important fact for this is that our coefficient has to be greater than or equal to 1, and a, the coefficient, has to be less than 10. We'll see that in an example in a moment. Our exponent, which is b, that has its own set of rules, and the first rule is that if it's a negative, our number is a decimal in standard form, and if it's positive, our number is greater than 1 in standard form. So let's look at some examples now and determine if they're in scientific notation and what the values would be in standard form. So in the first example, I've got 5 times 10 squared. My coefficient is less than 10, but greater than or equal to 1. That checks. And we have a power of 10. So this is a yes. It's standard form, or it's scientific notation. In standard form, this would be 5 times 100, which is 500. So this is scientific notation. The second example is 12 times 10 to the third. Well, my coefficient here is greater than 10. Right away, I can say this is a no. That is not in scientific notation as it stands. I can still find the value of this in standard form, but it's not in scientific notation. So this would be 12,000. Not scientific notation. The last example is 5 times 10 to the negative second. The coefficient is less than 10 but greater than or equal to 1. We have a power of 10. Both things check, so this is a yes. But the important thing here is with that negative exponent, our number will be less than 1 in standard form. It's going to be a decimal. So this is going to be 0.05 500ths. So that's how we can determine if something is in scientific notation and then what the equivalent values in standard form are. All right, so let's practice multiplying and dividing with scientific notation. So in the first example, we're asked to simplify 7 times 10 squared multiplied by 6 times 10 cubed. Now, as I observe the problem, all of the operations of multiplication, that's important because we can use commutative property with multiplication. We can reorder the values in any way, and we can still get the same result. So I'm going to reorder the coefficients and the powers of 10 to kind of group them. So 7 times 6 multiplied by 10 to the second times 10 to the third. And I've done that to group the like terms, if you will. And now I can see 7 times 6 is 42. And then I have a power times a power. They're the same base. And when I'm multiplying powers with the same base, I can add the exponents. So it looks like I'm done at this point. I've just got to make sure it's in scientific notation. And it's not, because 42 is greater than 10. So what we're going to do is we're going to divide by 10 here, which would make this 4.2. So if I reduce the coefficient by a factor of 10, I have to compensate and make the power of 10 bigger. So I've got 4.2 times 10 to the 6, and that's our answer in scientific notation. The last example is asking me to evaluate 41.83 times 10 to the 28th divided by 4.7 times 10 to the 18th. So some gnarly looking division in this, but we can do this nonetheless. So when we're dividing in scientific notation, we can divide the coefficients. So I'm going to write this down as 41.83 divided by 4.7. And we also know that when we're dividing powers of 10, we can subtract the exponents. This would be 10 to the 28th minus 18. From here, we can use a calculator for this. So 41.83 divided by 4.7 is 8.9. So I've got 8.9 times 10. Now 28 minus 18 is 10, so it's 8.9 times 10 to the 10th. I just have to ask myself, is my answer in scientific notation? My coefficient is less than 10 but greater than or equal to 1. I have a power of 10, so this is all set. It's in scientific notation.